So in the last test, we were measuring the bolt's radiated emissions in the screen room. Today we're turning the tables on the bolt and we're subjecting it to RF fields. And we're testing the bolt's ability to survive and operate correctly in the presence of high radiated fields. The bolt may find itself in these fields if you're using it for measuring power quality at, say, an AM radio tower or TV transmitter, or other situation where there are high power radiated fields. And there's no standard for this, but we're going along the guidelines of ICNIRP, which provides limits of about 25 volts per meter for the general public and closer to 60 volts per meter for occupational workers. And we're going to be up at that 60 volts per meter level in these tests. To do this, we have some equipment here. We have a function generator, which can generate signals up to a gigahertz. And then we have a couple of different power amplifiers. So today I'll be using this lower amplifier, which can amplify signals from 10 kilohertz up to 3 gigahertz with a 50 watt output. And we're routing its output through our reliable bird power meter and then into the screen room. We're also teed off from the function generator to look at what we're transmitting here with the spectrum analyzer, just as a sanity check. Now, to communicate with the bolt, we are using Wi-Fi. We're actually using Seeker as a Wi-Fi router, and the Seeker's Wi-Fi external port is connected through a feed-through into the screen room. Inside the screen room, we have 2 feed-through ports. This port is used for the Wi-Fi network inside, so this connects directly to the Seeker. And the second port is used to transfer the 50 watts of RF into the antenna. We have 2 different antennas. The slow periodic antenna is used for 300 megahertz to a gigahertz, and we'll go back to the biconical antenna for the lower band. And of course, the bolt is on the other end of the screen room. This is being subjected to the fields transmitted by the antenna. And just to verify that we're applying a significant amount of RF, we have a small little energy harvester. This is a diode that's powered by germanium diodes that is rectifying the RF field that it's being subjected to and powering the LED solely from that RF. So this is just a sanity check that we are generating significant amounts of energy. Now, to protect the Seeker's Wi-Fi port, we have an inline bandpass filter that filters out all signals except the 2.4 gigahertz network we're using. Of course, the bolt in the screen room doesn't have that sort of protection, so we're testing the bolt, not the Seeker here. Now, I will turn on the power amplifier, and we're set at 100% gain. And we can see on the power meter, we're at about 30 watts of power going into the antenna. And we can see the carrier here at 900 megahertz. And we are looking at live waveforms from the bolt. And I'm going to move the frequency around from a gigahertz and slide this up and down, as you can see this move, and verify that the bolt is still communicating through Wi-Fi and it's measuring correctly with the voltage waveforms as I go up and down in frequency. And the bolt is working normally and at all frequencies here in this band. Next, we'll switch to the biconical antenna and test from 30 megahertz to 300 megahertz. Well, we've tested the upper frequency band up to a gigahertz, which covered the PCS cell phone band and UHF transmitters. We've now switched to the biconical antenna in the screen room. To radiate efficiently in the lower band, we have a biconical antenna which can take up to a kilowatt of power. So we will repeat these tests. We haven't changed anything else, but in the lower frequency range, primarily to cover the AM and FM broadcast bands. So again, we can see what frequency we're transmitting at here on the spectrum analyzer. I'm going to turn on the power amplifier, and we're going to dial the frequency up and down, sweeping through the AM and FM broadcast bands from about 100 kilohertz up to past 100 megahertz. And we can see that the bolt is operating correctly. We're still getting live waveforms through its Wi-Fi connection, still measuring correctly as we dial this frequency up and down in this frequency range. So the bolt is operating correctly both in the low frequency band under 300 megahertz and up to a gigahertz. So it should be suitable for use near high power transmitters.